Hi, and welcome to an overview of SWM40, which is a module titled Introduction to Algorithms and Computation on the Master's level courses at University of Brighton. It's delivered by me, Aidan Delaney. Hi, that's me. And this is the overview for the academic year 2011 to 2012. Right, so what we'll cover on this module are several models of computation. We're going to have a look at that now in just a minute. And quite importantly, we're going to have a look at some of the algorithms associated with these models. So it's quite a traditional computer science course in a lot of respects. And if you've never encountered these differing models of computation, then you'll be introduced to actually, some brand new ways of thinking about computation or thinking about computing. These are the bread and butter of computer science, and they differ from thinking about computing in just code terms. We'll necessarily get into some kind of discussion on formal systems. I personally, my research area is in formal grammars and systems of formal logic, so I'm quite adept at this, and one of the reasons that I can help you through it, and one of the reasons that we get into this kind of formalisms is mainly because we can, and it's actually more easy to describe the interactions of models of computation or what's going on in the computer if you formalize this stuff, if we're exact on what we're talking about. It mainly lets us to treat very kind of complex semantic behavior that's going on inside of a machine effectively as interactions of more simple elements of syntax. We can treat it as kind of moving bits of syntax around rather than going really deep into the semantics. And these are the models of computation that we're going to be looking at. Again, very classic kind of bread and butter computer science. We'll start with regular languages. If you don't know what a regular language is, it's a very simple model of computation. If problems in the regular language space would be something like, let's spell check a word. We'll move up to discussing context-free languages, and at this stage we'll be talking about maybe grammar checking a sentence. Now, we're not going to do grammar checking, but that's the kind of problems that you'd be dealing with. Context-sensitive languages are more powerful again, and they would be able to do something like grammar check a page of text or a page of English text or something like that. But again, we'll have some better examples in the lectures. And then the entire world that we're concerned with as computer scientists is often just this set of computable numbers. And again, if you don't know what a computable number is, this is one of the reasons that this module is going to be great. We're going to actually show you exactly what a computer can do and exactly what it can't do. It is really well defined. There's no fuzziness here, really. It's not the case that we don't know what computers can't do. We know exactly what they can do. We know exactly what they can't do. Just so happens that the stuff that they can do is interesting and useful to industry as well. Okay, so here's a partial list of algorithms that we're going to cover in the lectures, just to make you aware that we are going to cover algorithms. We're going to look at different types of finite state machines, deterministic finite automata and non-deterministic finite automata, and we're going to figure out how to move between the two models or representations of the same model, I suppose. We're going to have a look at lambda NFA, lambda removal from that kind of stuff. We're going to look at regular expressions, which are extremely well used in general computing, and how they are just deterministic finite automata. So we'll look at converting from regular expressions to deterministic finite automata, and we'll look at converting back from deterministic finite automata to regular expressions. We're going to look at the equivalence of regular grammars and finite automata. I spend a lot of time at the regular grammar level because that's the area of my research and I know quite a bit about it. But we will look at the equivalence of non-deterministic push-down automata and context-free grammars. We'll have a look at some pumping lemmata for regular and context-free languages as well.
And the really interesting stuff is simulating Turing machines. What exactly is a Turing machine? What's the fastest Turing machine? Why can't we just add more processors to a computer and get faster computers? This explains exactly what computing is and why we can't go any faster, let's say, than we're currently going. Faster, I use the term very, very loosely here though. Spider diagrams, we're going to cover a bit on this. This is kind of my alternative way, well, not my, I didn't develop spider diagrams, but the view of spider diagrams through regular languages is something that's a focus of my research. And certainly if you've encountered some of the different formal languages or models of computation on your undergraduate course, you probably haven't encountered this at all. It's certainly a master's level worthy topic to look at. Our timetable, this is pretty much indicative. This year we're still trying to finalise it, but hopefully we're going to have some guest lectures from some extremely smart people from the University of Salerno in Italy, but we're not entirely sure where they're going to fit in right now. It all depends on flights and all that kind of stuff, the usual. So we're going to have a look in one of the lectures at in the first kind of 4 lectures at the levels of the Chomsky-Schutzenberger hierarchy that we previously kind of looked at, that onion skin model. We'll have a look at what it means to be a computer, so that's just kind of incompleteness, the Turing thesis, and then we'll have a look at ideas of complexity. Now, it will be myself covering the first half of this stuff, and then my colleague Andrew Fish, who will be covering a lot of the stuff on complexity, and then at the end I'm going to come back and cover the ideas of spider diagrams and my own personal little topic, spider diagrams of order. But this will be jiggled about at some stage. One, because we might find that you are interested in one particular topic more than one of the ones I've got here, and another reason is because these people may be coming over from Italy to give talks on algorithms in certain formats, so I'll drop a topic here or there. Software, I'll give it to you all the software that we need. All the software we need is open source. I use my own software to demonstrate some of the concepts on the course. It's written in Haskell, which is a lovely functional programming language. You don't need to be able to read it or to write it, but just I'll talk you through some of reading it. We may also wish to use JFlap, which is a fairly standard Java application for simulating finite state machines and things like that. Books, there are kind of 1 or 2 classic books on this. The Introduction to Automata Theory and Languages and Computation by Hopcroft, Motwani and Ullman is readily available, and it's pretty much a classic. And Introduction to the Theory of Computation by Sipser is again another brilliant and well written book. The first 2 books though on that list I have available on Student Central. The first one is via our ACM membership, and the second one is a Creative Commons licensed book. It's very good actually. It talks about models of computation, but it's more from a slightly kind of engineering perspective, from a circuit designer's perspective. So some of the chapters in it are really great. Some of them though are not really applicable to the way we're going to talk about things. I will provide you with a lot of reading material, but what I will do is actually point out the sections that you should read. There's got to be 2 or 3 books, but no, I'll be pointing to chapters. I'll be providing you with some papers as well. I will use a mixture of teaching styles. One of them is delivering some of the modules or some of the content over the internet like this. That's probably not going to happen again, but it's just this introduction it's useful to just have a video of. I will use slideware, so this kind of stuff, putting slides up on screen, chalk and talk, so get a whiteboard marker and scribble things down. Question and answer stuff, kind of standard Socratic method, and then we'll have a look at some independent study stuff as well. Usual thing, some people like different styles. If you don't like a particular style, bear with it, and remember your colleague may prefer it, because we don't all learn in the same way. But tell me, I'm quite happy if you don't like this particular mode of teaching, tell me, and we can modify it. And the other thing is, ask questions all the time. That's the only way to learn. Just ask questions all the time. Right. My email address is a.j.delaney@brighton.ac.uk. If you have any questions on this module, you know to email me there, otherwise just see me in class. Thank you very much.